Hi everyone. Today let's discuss about the topic BCD. Why BCD? Digital circuit store and process information using two valid signal. While people normally read and enter numbers in decimal form, BCD provides a direct method of representing decimal digits with binary signals, making decimal inputs, storage, arithmetic and display convenient. BCD stands for Binary Coded Decimal. It is binary coding system in which each decimal digits from 0 to 9 is represented separately by a 4-bit binary code words. The commonly used form is a 8421 BCD code. Those bit positions have a weights 8, 4, 2 and 1. BCD must not be treated as the ordinary binary representation of the complete decimal number. It is a digit by digit code. N is equal to 8B3 plus 4B2 plus 2B1 plus 1B0. For example, 0110 represent decimal 6 because 8 0 plus 4 1 plus 2 into 1 plus 1 0 is 6. Thus, 8421 BCD is a weighted code. Here, refer the table 8421 BCD coded table. For example, decimal digit 8 represented in a BCD code 1000. A 4-bit pattern has 16 possible combinations, but one decimal digit has only 10 possible values. Therefore, BCD uses 10 combinations and leaves 6 combinations unassigned. For a code 1010, which means binary value 10, it is invalid in BCD. And then decimal to BCD conversion. Convert each digits independently. Do not convert value numbers and binary values. Decimal to BCD conversion. First, there is a procedure. First, separate the decimal number into individual value and then replace every digit by its 4-bit 8421 BCD code. At last, retain the decimal point position when present. For example, convert 3962 BCD. 3966 is a decimal number. For a 3, the binary coded decimal is 0011. For 9, it is 1001. For 6, it is 0110. And next, convert BCD to decimal conversion. Divide the code into groups of 4 bits and replace each valid group by its decimal digits. If any groups lies between 1010 and 111, the code is invalid. Example, take a binary code decimal 0100 0010 and then 1004. Here 0100 is a BCD. For this, the decimal value is 4, and then for 0010 the decimal value is 2. For 1001 the decimal value is 9. So the total decimal number is 429. And then difference between BCD and pure binary. For decimal number greater than 9, BCD and pure binary produce different bit pattern because BCD encodes encode digits separately. If for a basic idea, 8421 BCD is encoded each decimal digit separately, but in pure binary convert the whole number. For example, decimal 183 8421 BCD is 001 100 0101, but in pure binary 10111001. In bits required for 185, BCD 8421 BCD is 12. In pure binary it is 8. And then decimal display 8421 BCD is direct and convenient, but in pure binary need conversion. And then storage efficiency for 8421 BCD is lower, pure binary is higher. Illegal 4-bit digit codes are codes 1010 to 111 for 8421 BCD, not applicable for pure binary. Arithmetic operation for 8421 BCD is bitwise with decimal correction, but for binary, ordinary binary arithmetic operations. And then BCD addition. BCD addition begins with the ordinary binary addition of each 4-bit digit groups, starting from the least significant decimal digit. A decimal correction is then applied whenever the temporary result is not valid BCD digits. Correction is required when either the 4-bit digit sum is greater than 1001 or a carry is produced from the 4-bit digit groups. Correction value is 0110. Here the decimal value is 6. Why 6? 4-bit represents 16 states, whereas 1 BCD digit use only 10 states. The difference 16 minus 10 equal to 6 accounts for the 6 illegal combinations. And then take an example. If we take a BCD value 0100 plus 0101, here 0100 is a 4, and then 0101's decimal value is 5. It comes 1001. It is 9. The decimal value is 9. So no correction is required. Another example, take 8 plus 7. Here decimal value of 8 is represented in BCD is 1000, and then decimal value of 7 is represented in BCD as 0111. And if we add both, we get 1111. It is invalid. The carry represents the 10 digits 1 and 0101 represent 5. Therefore, the BCD result is 0001 or decimal 15. And then BCD subtraction. BCD subtraction may be carried out by direct digit bitwise subtraction with borrow correction, but complement methods are more systematic. The common method uses the 9s or 10s complement of the decimal subtrahend. First, find the 9s complement by subtracting each decimal digit from 9, and then add 1 to obtain the 10th complement, and then add the 10th complement to the minus using BCD addition. If an n carry occurs, discard it. The remaining digits are the positive result. If there is no n carry, take the 10th complement of the sum and attach the minus sign. For example, the decimal number 38 is minus with decimal number 15, it gets the decimal number 23. For 38, BCD value is 00111000. For and then BCD value for 15 is 00010101. So the result is 00100011. And then storage forms and hardware implementations. Here unpacked BCD, one decimal digit is stored in a full byte, usually with the upper 4 bits set to 0 or used for zone or sign conventions. And then packed BCD. Two decimal digits are stored in 1 bytes, one digit in each 4 byte nibble. This improves storage efficiency. Some commercial packed decimal format reserve a final nibble for the sign. And then advantage of BCD. It is simple decimal convention. Each decimal digits map directly to 1 4-bit codes and convenient input and output. Convenient input and output means decimal keypads, counters, displays can be interfaced easily. And then exact decimal digit representation. In this, every entered decimal digit is stored without binary fraction convention at the digital level. And then direct decimal arithmetics. Arithmetics can be performed on coded decimal digits without converting the complete number to pure binary. Next used in easy digit extraction. Individual decimal digits are directly available for comparisons, display and formatting. And then disadvantage of BCD. More storage. It means 4 bits are required for every decimal digits, often more than the equivalent pure binary representations. And then wasted combinations. 6 of the 16 4-bits patterns are unused and want more hardware because BCD arithmetic needs correction detector, extra adders and carry logics. And then applications of BCD. It is used in electronic calculators and cash registers, digital clocks, digital watches and timers, digital voltmeters, multimeters and frequency counters, 7-segment display systems, electronic weight machines, industrial counters, etc. Thank you.